We start with chapter 4. The chapter 4 is a little bit more based upon the chapter 3. First come, first serve, and I make a little bit more copies of the first part of the slides, only 3 copies. I don't know. Otherwise, the whole thing is available on Blackboard. Okay, so chapter 4 is about the vibrations on the general force. The topic in chapter 3 is a specific type of the force. In chapter 3, we deal with harmonic force. Harmonic force is kind of sinusoidal things. And chapter 4, we based upon that one, we extend. We are dealing with the general periodic or non-periodic. Okay, so that means in these chapters we are going to talk about is this. This is the handout, the kind of things. The first portion, and the one some of you have the first portion is this one, and I'm still revising my contents for come up with the second portions. For non-harmonic force, and for example, we're in chapter 3 we're dealing with is this one, and we might have impulse. Impulse is something like this. Okay, we apply the force. The force applied in simply in the very short amount of time, we call the impulse, just like this. Okay, like this one, and or we can call this one called the step input. Step input, that means the magnitude of the force is constant over time. And the step can be unit step or general step, depends on the magnitude. And we have the combined ramp. So ramp is the force. That means this time is increasing over time with certain slope. Okay? So this is a force. And this is the combined ramp and the step input. Okay, so basically this is kind of capped by some info. And here is a regular pulse excitations. So, and pulse excitation, you know, just like step motors. Okay, if you play the step motor is kind of something like this. Okay, kind of stepwise, and do the step motor basically using the step either in PWM, pulse wide modulations or whatever, provide us the equivalent amount of the loading or steps to move on. Okay. So in this way, this one is also common in our things, and also we have half sine or half cosine wave, the wave pulse. Okay, rather than square, we have the wave line. Okay. And then this one is very general combinations of the different harmonic frequencies. So say sine omega t plus sine 2 omega t, etc. The different frequencies. If you decompose this one into the frequency domain, you will see that there's a few the frequencies appear on the spectrum. Okay. And then this is the most general. Basically, we have an arbitrary force, and that is not periodic, not regular. And these chapters, we're going to spend time to see how can we calculate for steady state response to those general force. In this regard, I can tell you most of the techniques we learned in chapter 3 is only good. It's only good for this. So this is again, I said this is the harmonic functions of various frequencies. All of our techniques we learned in chapter 3 only good for this. Okay. For the others, I'm sorry, we have to pick up another mathematical tool to deal with other things. Okay, so keep this in mind. And again, these chapters will be also, I would say, mathematical and maybe calculational rigorous. Okay. So in this way, the first portion, the first part I decided is go to the response on the periodic force. And so that means in the first portion, I will, based upon what we know from chapter 3, to deal with this kind of the force in general. Okay. Then the second portion, the second part, will be the new tools. And the new tools, mathematical tools, we can pick up to deal with many other things there. The new tools based upon the Laplace transform, and that one's supposed to be introduced in 3.13. I just decided to move that one to here because that will be continuous. Okay, so to this point, and that pretty much will be another test, and yeah. Okay, so that is the goal here. So now we go to, so now we can have a new section. Yeah.